So looking at the female gametophyte, it is similar how it develops to the male gametophyte. So like the male gametophyte, the female gametophyte, that is the megagametophyte, remember it comes from the megaspore, okay, from the large spore. It begins when the megaspore are still inside the megasporangium, okay. So we saw in the male gametophyte, remember, the spores, they start developing inside the sporophyte, okay, inside the plant body, okay, inside the sporangium. So here also, the megaspore will start to develop inside the sporangium, that is the megasporangium. So looking at this image, that is the megaspore. You have an outer wall and inner wall, that is your outer exine and inner intine. Then you can see a huge vacuole, no? Here, the nuclei are at the side. Wait. You can see that the nucleus, they are here in the side, and in the center, it's a complete vacuole, okay? So the nucleus, they are in the side, all right. So this is expanded from another angle. The nucleus, all the nucleus are here in the side, here, and the center is a vacuole, okay. So there is a tissue there at the top. Then this side one, these are the exine. Okay, so you can see that the rhizoids are starting to come out. Okay, you can see the rhizoids are coming out. You can see the archegonia, and there you can see the zygote inside. Can I expand this? Okay, see, you can see the archegonia. We will see how it develops, the archegonia. You can see the zygote. Then you can see the embryos, okay. So this one is one zygote. This one is, this is one zygote. Oh, 1 minute, the brush. Okay, this is one zygote. This is another zygote, okay. This zygote, this one also, no, this zygote, this one, this zygote also will grow up to become an embryo like that. Okay, so let's see. Now remember, I told you a big vacuole in the middle. So let's see how it starts. First, it will start by appearing a big, very much visible vacuole will develop. That is, a conspicuous vacuole will develop within the cytoplasm of the megaspore and at a very early stage. Okay, so the first stage will start with the big space, that big vacuole formation. Then the megaspore nucleus will undergo repeated nuclear division. Remember, we saw so many free nuclei. So from one nucleus, it will keep on dividing, keep on undergoing mitosis until we get so many nuclei. So thus the megaspore will undergo repeated nuclear division without cell wall formation. Okay, since there is no cell wall formation, so the nucleus are all in the same cytoplasm. So that is what it means, okay, by a free nuclei. If there is a cell wall, suppose let's say, hypothetically, just imagining, suppose one nucleus is divided into two and then a wall formation happened. So that becomes two cells. They are not free nuclei. But here, from one nucleus, it divided into two, but there was no formation of a wall. So the nucleus are all in the same cytoplasm. So we say nuclei, free nuclei division, okay, or free nuclear division. Okay. As a result, we see a thin layer of multinucleate cytoplasm around the large vacuole, okay, because there was free nuclear division, so there's so many nuclei. So there'll be a thin layer of multinucleate cytoplasm that is around the vacuole. So then the formation of cell wall around each nucleus will start. Okay, remember there was a tissue at the top. Those are the ones whose let me show you. This one, no? You saw that tissue there? This one? There, you saw that tissue? This is because the cell walls have formed. Let's go down again. So the formation of the cell wall will start around each nucleus, with starting at the apical end. Okay, beneath the triradiate ridge and an apical patch of cells, 2 or 3 layer thick is formed. So that's why we see those tissues at the top. So that's why we saw those tissues at the top, okay, because the wall formation starts from the apical part, okay, from the apex. Okay. So in some species, the cell wall formation will continue until the megagametophyte is entire cellular, okay. So until all those nuclei are completely covered, are completely having cell wall, okay, in some species. While in other species, for example, Selaginella crossyana, here this one, Selaginella crossyana, the apical patch, those cells of the apical part, means at the tip, they will be separated from the rest of the gametophyte by diaphragm, means by a wall, okay. So this one we are seeing here, crossyana. Here we are seeing the crossyana, no? You see, there is some sort of a wall. There's some sort of a wall that separates this cellular tissue from the rest of the flea nuclear tissue down, okay? Then at the end of it all, the vacuole will be slowly removed, okay? Because all the cells will have a wall. So the vacuole is obliterated by the formation of the cells. The stage at which the megaspore is shed from the megasporangium varies from species to species. Okay, so in majority of the species, the final stages of female gametophyte development and fertilization and germination of young sporophyte takes place while the megaspore is within its enclosed megagametophyte. 1 minute. Sounds incomplete. Something is missing. Okay, let's read again. The stage at which the megaspore will be sent out of the megasporangium, it changes from species to species, okay? But in most of the species, the final stage of the female gametophyte development and fertilization and germination of the new young sporophyte takes place while the megaspore is within its megagametophyte and it rests on the substratum. Means in most of them, it will still be inside that, the megasporangium, okay, while it's still in the mother, okay, the megasporangium. So the female gametophyte will increase in size and it will exert pressure on the megaspore wall, okay. So as this female gametophyte will keep on increasing in size, then it will split open the megaspore wall along the triradiate ridge. So here we saw the splitting, no? Here in image D, this one you can see that it has the female gametophyte has increased so much in size that it splits along the triradiate ridge. Okay. Then remember we saw some rhizoids below. So tuft of rhizoids may be developed from the exposed gametophytic tissue, which play a role in the absorption of water and nutrients and also in the anchorage. Okay. However, in Selaginella rupestris, the megaspore are not shed and the development of the female gametophyte and fertilization takes place in situ, and the young sporophyte can be seen developing on the parent plant. Okay, so in Rupestris, from the parent plant itself, it will not be shed. So it's like the child will grow in the mother's belly forever. Okay, it will grow on the mother's only. It will not be shed.